I present to you the solution to the problem find y prime if y equals e raised to x times e raised to ln of x. Looking at the function given, it is exponential in nature. But prior to differentiating the given, we will simplify it or simplify first the given. How can we simplify the given? Applying your properties of logarithms. Okay, laws of logarithms. Particularly the factor e raised to ln of x. We can still simplify this. Note that e raised to ln of x is x. Why? How come that e raised to ln of x is equal to x? Note that e raised to the natural logarithm of x is equal to x. Now the question is why? How come? Okay, so let's justify. So we let m, let's say m be equal to e raised to ln of x. And then from here, we take the natural logarithm of both sides. Okay, taking the logarithm of both sides, we'll get the natural logarithm of m equals the natural logarithm of e raised to the natural logarithm of x. However, from our laws of logarithms, the logarithm of a power is equal to the power times the logarithm of the base. Okay, so we can rewrite this into the natural logarithm of m equals what happens to the power or to the exponent natural logarithm of x? It becomes a factor. Okay, so equals ln of x, the natural logarithm of x, times ln of e. However, ln of e is equal to 1. Okay, the natural logarithm of e equals 1. So please do not forget that. That's a property of logarithm. So this one therefore is reduced to ln of m equals ln of x. However, there is also a property or equality of logarithms. Equality of logarithms. Logarithm of m is equal to the natural logarithm of m equals the natural logarithm of x if and only if m equals x. Okay, so from here, m is equal to x. And take note that our m is e to the ln of x. So we can replace this now with x. Therefore, our given is reduced to e raised to x times x. And note that this is a product between e to the x and x. So to differentiate or to get y prime, we have to apply then the product rule, u dv times v du. So if our function takes the form uv, then derivative is u times dv plus v times du. So let's apply that here. Our u is the first factor, which is e to the x. So y prime is equal to u e to the x times dv is derivative of x is 1 plus v, which is x, times the derivative of the first is e to the x. Or simply, y prime equals, you factor out e to the x, giving 1 plus x. Okay, the other factor is 1 plus x. So e to the x times the quantity 1 plus x. Okay, now what happens if you leave it as it is? It's alright, you can leave it as it is, applying also product rule. So let me show you another solution. Or if you want to differentiate the function as it is, y is equal to e raised to x, e raised to the natural logarithm of x, then y prime is equal to, this time, our u is the first factor and our v is the second factor. Then we can simplify it later. Okay, so let's continue finding the derivative. Y equal to, let this be our u. Okay, so y prime, therefore, y prime then is equal to u dv times v du u e to the x, dv, derivative of e to the ln of x is e to the ln of x times derivative of ln of x, which is 1 over x, plus v du e raised to ln of x times derivative of e to the x is e to the x. Okay, so when simplified or when put together, y prime is equal to e to the x is common to both, and even e to the ln of x. So e to the x times e raised to ln of x times 1 over x plus 1. However, if you want to use the property, it's okay. But e raised to ln of x is equal to x. So you can still simplify this into y prime equals, let's find out if we'll end up with the same answer, e raised to x times 1 over x plus 1. Okay, what will y prime be? Okay, so this one becomes, after multiplying each term inside the parenthesis, will end up with e raised to x, and then x here with this x will cancel out, so that gives e to the x only, plus e to the x times x. And when factored out, y prime equals e to the x times 1 plus x. Is this equal to the previous? Now let's compare, and that's it. Equal to the previous. Or you may even have this solution, the other solution, expressing the product of powers of the same bases by using laws of exponents. Y equal to e to the x times e raised to ln of x could be expressed as e raised to x plus the natural logarithm of x. And then y prime, by applying e to the u du, y prime equals e raised to x plus the natural logarithm of x times the derivative of the exponent, which is derivative of x is 1 plus derivative of ln of x is 1 over x. Okay, so y prime equals e to the x plus ln of x times 1 plus 1 over x. Then you can again express it into e to the x times e to the ln of x times 1 plus 1 over x. Take note that you'll end up with the same answer as the previous. Okay, so y prime here equals e to the x, and then again, you know that this is equal to x, so times x times 1 plus 1 over x, which when simplified, y prime gives x e to the x plus e to the x. That's after multiplying this with each term inside the parenthesis. And when factored out, it gives e to the x times x plus 1, which is equal to the previous two answers. Okay? Okay. Or that one presented by one of your classmates, his or her answer is y equals e to the x, e raised to ln of x, and y prime is equal to the first times derivative of the second is 1 plus the second, e raised to ln of x, times derivative of the first is e to the x. Okay, so y prime is equal to e to the x times 1 plus e raised to ln of x. But again, when simplified, y prime is still equal to e to the x times, what is this equal to? Okay, what is this equal to? Again, note that e to the ln of x is equal to x. Okay? And so, this will further be simplified to 1 plus x. This is correct. This is also correct. Okay? And that's it.